It's an incredible volcano. It's this 5 kilometer wide caldera in which sits Chonji, or Heaven Lake, with about 2/3 of the volcano in China and about 1/3 of the volcano in the DPRK. The lake and the caldera itself was thought to have been formed from a very large eruption in the year 946 that's up there with some of the biggest in human history. Yet despite that, and despite this history, we don't really understand why the volcano is there. It doesn't sit on a plate boundary such as the nearby volcanoes in Japan. And so the kind of origin story behind it, why it's there at all, is a bit of a scientific question. One of the things we've learned over the last 10 years of working on Mount Paektu is the importance of the volcano to all Korean people. It's embedded within the kind of origin story of the Korean people, back to their kind of founder, Dangun. You see it in both the north and south of Korea, in the national anthem, in pictures around the country. Yeah, in the north in particular, it's embedded within the recent history of the volcano, of the country. And so you see this symbol in subway stations, on news reports, in the national emblem, everywhere. So it's clear that this volcano is of huge symbolic importance to the Korean people. We've been working on the volcano about 10 years now, and we were invited there by the DPRK scientists in 2011. And the reason for that was in about the year 2002 to 2005, there was a significant period of unrest on the volcano. There was increased seismic activity, change in the nature of gas emissions, and ground deformation. It's all linked to a magmatic recharge event beneath the volcano. So the DPRK scientists reached out for international scientists to see if we could set up some sort of collaboration. And so myself and a colleague, Clive Oppenheimer, we responded to that. And we traveled to the DPRK. We spent about 2 weeks on the volcano, understanding the work that the scientists there have been doing on the volcano, and really discussing ways we could set up joint projects together. And that really has led to this 10-year long collaboration. We think that the volcano itself presents a unique opportunity for scientific engagement. We were the first Western scientists to visit their volcano observatories. It's the first dedicated cross-border study of the volcano, where we work together with Chinese and DPRK scientists. And also what it's done is it's allowed us to navigate a path through a very turbulent political time on the Korean peninsula. Our DPRK colleagues from the very first day, have made us very, very welcome. But we also work closely with local DPRK people, local villages and farmers who look after our seismic stations, for example, during the winter months, and again have been made to feel very welcome. So it's definitely giving us another view of the DPRK to what you might see commonly portrayed in the news. One of the biggest challenges we faced through the project was actually from the international sanctions. We quickly realized that it wasn't going to be so simple as other collaborations. And it took about 18-month discussion with the UK government, with the US government, to find a way in which we could take our equipment, in particular the seismometers, to DPRK as part of this project. Working on the volcano has been a truly unique experience. It's an incredible place, and it's absolutely beautiful. On the DPRK side, it's like a tundra kind of landscape, and that's largely testament to the huge amounts of pumice that were deposited from the 946 eruption, and that environment hasn't recovered, compared to the Chinese side, where less material was deposited. It was very dense forests, and that's regrown. So environmentally, it's fascinating and a very beautiful place to work. In 2020, we published a new paper using the seismic data we collected in DPRK. And this was exciting for two reasons, really. One, because it was the first cross-border geophysical project done in collaboration with our colleagues in China and the DPRK, but also because it allowed us to image the magmatic system beneath the volcano. And what we found by using earthquake data from all over the world was we could identify regions of low seismic velocity, which we associate with evidence for partial melt. And we see the top of a chamber at about 6 kilometers depth that extends about 20 kilometers laterally. And we think this is a sign of some sort of deeper magmatic system that might be feeding the shallower magma system, which would lead to the 946 eruption and possibly may have been involved within the period of unrest between 2002 and 2005. We have also worked on dating the Millennium eruption. So our colleagues in China had collected or identified in the pyroclastic flow deposits a rather remarkable tree that was over 250 years old when it was killed. And they had already used this to do radiocarbon dating of the Millennium eruption. But using traditional methods of this, you could get an accuracy to within a few years of the eruption date itself. And so there was still considerable uncertainty about this. Now, my colleague Clive Oppenheimer, and working with Xu Jiandong at the China Earthquake Administration in particular, and colleagues there, they recognized that it was known in the literature that in the year 774 there was a burst of solar radiation, likely due to a solar flare, that can be seen in the radiocarbon data. And knowing that the tree was alive during this year, what we could do is if we could identify the tree ring which contained this spike in carbon-14, we would have a simple task of counting to the tree rings to the edge of the tree, and we would identify exactly when this when the eruption happened. And so we did this, and indeed we found that it happened in the year 946. But better than that, we could see that the last tree ring was in its state of late stage growth, which meant it must have happened late in that year or early in the year 947. And even further from that, we could identify from the ice cores where ash has been found from the Millennium eruption, because it was so big, you could see that the stage of ice growth also suggested it must have happened towards the end of 946. Our collaboration with the DPRK scientists is ongoing. We've recently set up the Mount Pektu Research Centre to facilitate these projects, and we've got funding now for a much bigger, more ambitious deployment. And that deployment is really targeted at understanding the origins and the driving mechanisms of the volcano. So previously we'd focused just on Mount Pektu itself. Now we're trying to look at the much wider region of volcanism within northern DPRK and northeast China. So we're planning a new deployment of seismometers in DPRK to coincide with the deployment of seismometers led by the China Earthquake Administration in China. So COVID depending, hopefully we'll be there this summer.